welcome to OAuth for Java developers. My name is Matt Raible. I'm a hick from the sticks. I grew up in the backwoods of Montana with no electricity, no running water, and I had to walk 2 miles to the bus stop every day. But the cool thing was in the winter we got to ski. So I'm one of those people that only in the last 10 years realized I have 10,000 hours of cross-country skiing in, and I happen to be pretty good at it. So I finally went and bought some cross-country skis. Pretty fun. That's the cabin on the left there that I grew up in. That's my parents' bedroom on the right. I live in Denver, Colorado with my beautiful wife, Trish. My 2 awesome kids, Abby and Jack. You can tell this photo is a bit dated because Jack is about 6 inches taller than I am right now. So if you have kids that are like 12 or 13 years old, watch out. Like the next 3 years, they really grow a whole lot. I also have a middle child. His name is Hefe, after Hefeweizen. I like to think that he's, colored like Hefeweizen. He's from Germany, right? He was built up in Hanover. And you could call him an expensive obsession. If you have a similar obsession with old classic Volkswagens, I'd love to talk to you after. I work for a company called Okta. My dad called it Okra for the first 4 years, and now he's graduated to Okta. He's still not quite at Okta, but the term actually means unit of cloud measurement. So an 8 Okta day means it's very cloudy, and a 0 Okta day means it's not a cloud in the sky. So Okta joined with Auth0 a couple years ago, and their CEO's name is Eugenio Pace. And when I first looked at his bio, I was like, this guy and I are going to get along very well, because he said in his spare time he enjoys the outdoors, rowing, riding bikes, spending time with his family, and restoring his 1970 Karmann Ghia, which is a classic Volkswagen. So him and I get along great. We now call it Auth0 by Okta, and it powers our customer identity cloud. So today we're going to talk about what the heck is OAuth. We'll talk about Java's OAuth 2 support. I'll do a little demo and show you some OAuth 2 in action. And then we'll talk about Java's security frameworks and their OAuth support. And then we'll talk a bit about OAuth 2 authorization servers. So before we begin, I do have some stickers that someone gave me earlier. So here's Apache Shiro. If anyone wants an Apache Shiro sticker, I'll put them up there. You can grab them after. And I also have some books. So what typically happens is I'm going to use the whole time. And at the end, I'm going to say, who has questions? And then you're going to raise our hands, and then someone's going to be like, no, it's my turn to talk, out of here, right? So typically, I don't have time to answer questions at the end because I use it all. So I have this book here, the JHipster mini book that I wrote, used ASCII Doctor. It's all printed. Just got these a couple days ago. Actually, I called the Uber. Then they arrived. Then I brought them here. So they arrived just in time. And the reason I mention that is if you have a question during the talk, raise your hand, ask it, and I will give you a book for asking a question. Now, it has to be a good question. Can I have a book doesn't count. But otherwise, if you have any questions during it, please let me know. So let's start with a bit of history. When we first started creating web pages back in the 90s, we used basic authentication, and it worked pretty well, right? You just configure it in your Apache web server or maybe in Tomcat, popped up a little dialog, and you were like, that's cool that works, right? And it eventually evolved into form-based authentication because we had clients or we had customers that said, can you style that login form so it looks a bit different? And so then you got form-based authentication, and then you actually had to store like credentials in a database. And then you learned about passwords. You learned about hashing. You learned about salting. And it's basically, not a lot of fun. So to create a better system for the web, federated identity was created for single sign-on. And there are 2 main players in a federated identity system, an identity provider and a service provider. And often the service provider is just the application that you need to log into, and the IDP is a provider of the users that log in. And so federated identity was made famous by SAML 2.0, an OASIS standard that was released on March 15th, 2005. Remember that date, 2005. There's probably some of you here that might not even been born yet, right? So it's a large spec, but the 2 main components are its authentication request protocol and the way it packages identity attributes and signs them, called SAML assertions. So if you're an Okta customer, anyone using Okta, like have a dashboard with chiclets that they click on to log into things? Nobody? Oh, we got one. So I could take you out for a steak dinner. But basically, we do this with our SSO chiclets, right? You log into Okta, you click on a chiclet, and then you get this identity information, after you've logged in. Inside the assertion, it says who the user is and that it came from Okta. and slap a digital signature on it, and you're good to go. And so this is what a SAML assertion looks like, and I've highlighted the important parts in blue. And you can see there's a lot of noise in here, right? Typically, that's how XML works, but also, there's got to be a better way. So anyway, SAML is basically doing a session cookie in your browser that gives you access to web apps. It's limited in the kind of devices and scenarios you might want to do outside of a web browser. And a lot has changed since we were building, things back in 2005. We build APIs now. Back then, there wasn't as many APIs built. If they were building APIs, they were using WS Star or web services, right? And so when SAML was launched in 2005, it made sense, but a lot has changed since then. And so OAuth stands for Open Authorization, and there are two versions of OAuth. There's OAuth 1.0a and OAuth 2.0. And these specifications are completely different from each other and cannot be used together. There's no backwards compatibility at all between them. And whenever I say OAuth, from now on, I'll be talking about OAuth 2.0. And so we try to say the version number all the time because you don't just want to talk about OAuth in general, you want to talk about a specific version. And so there's a lot of confusion online if you search for OAuth and try to figure out what it is. There's lots of jargon, lots of incorrect info, and there's an answer on Stack Overflow that gets really high rankings, and then there's a guy in the comments that says, no, you're wrong, points to his blog post. You go to the blog post, and then there's someone that comments on there and says, no, you're wrong. So, it's a friggin' spec. Why is it so difficult to understand? If you look at the HTTP spec, everyone kind of gets it and agrees on it, right? But OAuth, it's very intimidating, and what I hope to do today is make it less confusing and less intimidating. So in 2006, there were a few identity use cases, right? There was simple login, basic login, form-based login, or using session cookies. Single sign-on across websites, you could do a SAML. Mobile apps didn't exist. Delegated authorization didn't exist. The iPhone wasn't released until June 29th, 2007. So in 2006, didn't have any of those concerns. So this gave rise to the delegated authorization problem. And the pattern or request for the pattern wasn't even around in 2006. And basically it is, how can you let a website access your data without giving it your password? So if you're old like me, you might remember Yelp or LinkedIn. They both did this back in 2006. When you would sign up and complete, your sign up process, they would prompt you for your Gmail, username, and password. And it says here, and don't worry, we don't keep your email password or your friends' addresses. We loathe spam too. And you're like, I don't know if I believe them, right? Like it says it, but there's no guarantee. They could keep your password around and try it again in a couple months and see if they can, get more contacts. So the idea was they'd, log in, grab your contacts, and then throw away your password. I don't know if they actually did that. I didn't work there. Hopefully they did. But it's one of those things that people were fine with the pattern because we all remembered our Gmail password, right? We didn't have password managers back then. It was easy to just type it in. And so there's a better way to do this today. If you've ever seen a dialogue like this, you've basically used OAuth. This is an application asking Facebook if it can access my data on its behalf. And so the delegated authorization problem inspired OAuth. And a nice way to think about it is like hotel key cards, but for apps. So if you have a hotel key card, you can get access to your room, but there's no identity information in there. You can also access the pool, maybe you can access the gym, and it just unlocks the door for you. And how do you get a hotel key card? Well, you have to do an authentication process at the front desk. And after authenticating, right, you give them your ID or you give them a driver's license, passport, and obtaining the key card, you can access resources across the hotel. And so delegated authorization with OAuth 2 is basically saying I trust Gmail and I kind of trust Yelp, and I want Yelp to have access to my contacts only. I don't want them to be reading my email, right? That could be dangerous. And so typically how it works in today's scenario with OAuth, instead of prompting you for your credentials, it'll have a button that says connect with Google or sign in with Google or sign in with LinkedIn. And what it'll do is it'll go from Yelp to your authorization server or your identity provider. In this case, it's Google, and chances are you're already logged in, right? So you're not prompted for credentials. You just get a consent screen that says, do you allow Yelp to access your contacts? And then it goes back to Yelp, and then they can access your contacts. So that's a very minimal example, and this diagram will get more complex as we go. So OAuth terminology is primarily what makes it confusing. In my opinion, there's actors, there's clients. A client is the most overloaded word, right, in software development. So in this case, it's usually an application. There's an authorization server, there's resource servers, there's access tokens, and there's redirect URIs. So I'll try to define each of these terms so you understand them a little better. So the actors in OAuth flow are as follows. There's a resource owner. They're the ones that own the data in the resource server. For example, I'm the resource owner of my Facebook profile. Resource server is the API which stores the data that the application wants to access. The client is the application that wants to access your data, and the authorization server is the main engine of OAuth. And so the resource owner is a role that can change with different credentials. It can be an end user, can also be a company, and in some cases it's like machine to machine. For example, Google's authorization server with Gmail as the resource server. And when it comes to clients, clients can be public and confidential. And there's a significant distinction between the two in OAuth nomenclature. Confidential clients can be trusted to store a secret. They're not running on a desktop or distributed through an app store. People can't reverse engineer them and get the secret key. They're running in a protected area where users can't access them. Public clients are browsers, mobile apps, and IoT devices. TVs, I think, might even be public, right? You might be able to hack them. But basically, the whole idea is if you see a client secret in a spa app, they're doing OAuth wrong. Like, contact someone, it's a security incident. Client registration is also a key component of OAuth. So in the US, we call it the DMV. It's the Department of Motor Vehicles. If you need a license plate, you go there, you get a license plate, and then that's a client ID. So you have to register your app oftentimes. This is an example using Google here. You can see we're saying it's a web application. We give it a name. You can authorize certain JavaScript origins, which are URLs, and then redirect URIs. You might upload a logo, right? So when someone logs into your app, they actually see your logo on the screen. And then tokens are received or retrieved from endpoints on the authorization server. So there's two main endpoints. There's the authorized endpoint and the token endpoint. And as far as the path for those, it doesn't really matter. And here you can see I have OAuth 2 as a prefix, but different IDPs will implement this differently. And they're separate for different use cases. So, you know, if you have a refresh token, it will go to the token endpoint to get a new access token. And then the token endpoint will give you a new access token. And then if you want to introspect the access token to see if it's valid, you can do that with the introspect endpoint. And so OAuth has two types of tokens. There's an access token and a refresh token. And access tokens are basically used to access the resource server or the API. And they're meant to be short-lived. Think of it as in minutes and hours, not days and months. And the other token is the refresh token, which is much longer lived, days, months, even years. And they can be used to get new tokens. And refresh tokens can be revoked. Access tokens cannot. And when revoking an application's access in like your Twitter account or in your Facebook account, you're killing the refresh token. And so it's no longer available to get a new access token. And then OAuth doesn't define the format of a token. So oftentimes you'll hear about JOTs or JWTs, and it doesn't need to be, the access token doesn't need to be a JWT. It's just a random string of characters. So guess what? When you have a JWT that hasn't been decoded, it is just a random string of characters, right? So it basically, there's self-encoded tokens. That is a JWT. You can do that. Or you can do the opaque tokens, which, again, random string of characters. And the OAuth spec doesn't define it, so you can use either of those. And so let's go through the flow again with these terms defined. So you start with Yelp. The resource owner clicks on the button, connect with Google. You go to the authorization server. As part of your application, you will specify a redirect URI and the response type. And so you go to the authorization server, comes back to that redirect URI with authorization code, and then it exchanges the code for the access token. Once you have that access token, you can talk to the resource server. And so some more OAuth 2 terminology: scopes, consent, and grants. And again, a lot of these things are what makes, OAuth confusing. So scopes are just additive bundles of permissions asked by the client when requesting a token. And it decouples the authorization policy from enforcement. So should be able to read that. I know it's really small, but it basically says that, Facebook, you're giving it permission to access your timeline, to post new tweets on your behalf. And it also says scopes to deny does not allow you to read Twitter password. And it's like, whew, that's good, right? I'm glad it can't do that. But you will be prompted with this, and ideally, you can choose whether you want to give it those permissions or not. And they're coded by the application developer when writing the application. So if we look at the flow again with scopes and consent defined, you'll see most things are the same except for the scope there. Right? Now we're specifying profile and contacts. That's, what we're giving the permission to the user to access. And then we're requesting consent from the resource owner. Otherwise, everything's the same. Now we've talked a bit about the client types, the token types, and the endpoints of an authorization server, and how we can pass tokens to a resource server. There's two different flows I mentioned: the authorization code and getting the tokens. And those don't have to happen on the same channel. So the front channel is what happens over the browser. When you redirect and you see, a new URL up there, and the user gives consent, this happens on the user's browser. The back channel is a direct HTTP call directly from the client application to the resource server to exchange the authorization grant for tokens. And actually, that's incorrect. Not the resource server, the authorization server. And these channels are used for different flows depending on what device capabilities the user has. So an authorization request on the wire looks like this. We're specifying the scopes, we're specifying the redirect URI, the response type, the client ID. Again, the client ID is like an actual license plate. It just identifies you, the state, and then the response is typically a redirect back to the application. Did you have a question there? So the question is, for refresh tokens, does the same problem exist like hashes for a database and passwords in a database? Is that correct? So typically the refresh tokens probably aren't stored by the authorization server. I don't know how that's implemented. That's not part of OAuth. It's just saying that, a refresh token is on the client and it has that information in it that says it's not expired. And so as long as it's valid, they should be able to get a new one. As far as people stealing a refresh token, that's why you might not want to store it in local storage in a SPA app, right? And one of the things I've seen is implemented where refresh tokens are one time only. You can only use them once. So if it's already been renewed, can't be used again. Does that help? Right, but if you're doing like refresh tokens with Spring Security, for instance, and it's all happening on the server, shouldn't be an issue. Shouldn't be able to steal them, right? Because it's in a session and that's encrypted and difficult to get. I mean, it's possible, right? Like, if you get in and get that information from the application, then yeah, possibly. Did you want a book? All right, I'll leave it out here and you can grab it at your convenience. So the question was about refresh tokens and having them very long lived can be a security risk. Is that correct? Yeah, so refresh tokens typically, maybe a week. You can do it years. What Facebook had a couple years ago is they actually had their access tokens available for like a year. And so the thing with access tokens, if you steal an access token, you have the ability to act as that user and get that information, right? And then typically if it doesn't expire, it's still valid. So with refresh tokens, yeah, the shorter it can live, the better. And a lot of these things can be taken care of by frameworks or tools, right? There's usually the way to deal with access tokens or refresh tokens is, proactively, where you basically have a timer and you actually, refresh the token before it expires. In your app, you're looking for that. Or reactively, which means, try catch, and once that access token is invalid, then you try to get a new one. Does that help? Right. Yep. Would you like a book? All right. I'll put it out here for you. 2 down, 2 to go. All right. So this is what, the request response look like. And then the token request, after you've gotten the code, will look like this. And you'll see it's actually using a client secret there. So this is happening on the back channel. It's not exposed in the browser. Still got that redirect URI in there. And then the response will be the access token, token type, when it expires, and the refresh token. And to get a refresh token, you do have to pass in a certain scope, right? You have to say offline access. If you don't pass that in, the identity provider won't actually give you that refresh token. And once you have that access token, you can use it in a header, authorization header. So if you're doing basic authentication, right, it's still an authorization header, but it says basic instead of bearer, and then it's a username and password separated by a colon and base64 encoded. So, this isn't really anything special. The access token is an access token, right? And then you can get your messages using it. So now you have a front channel, back channel, different endpoints, and different clients. And you have to mix and match these based on different use cases. So this up-levels the complexity of OAuth, and it can get confusing. So to go through the flow again with front and back channel defined, everything's the same at this point, but you're going to the authorization server on the front channel, you're requesting consent on the front channel, you're back to the redirect URI, back to your app on the front channel, but then everything else happens on the back channel. And so there's a number of different flows or grant types for OAuth. The first is what we call implicit flow. Don't use it. If you're using it, stop using it. It's basically invented 2009, before we had the ability to do XHR or CORS, right? Cross-origin resource sharing. The servers, web servers, browsers didn't support cross-origin resource sharing. So basically, the access token will come back to you in the URL. It's usually in a hash, and a lot of times web server logs don't, record the hash, but it might. So it's one of those things that if you have an access token in the browser, it ends up in your server logs, not a good thing. Authorization code flow is basically the gold standard. Everything happens on the front channel to exchange the code, from the back channel, and everything works pretty nicely. There's also client credentials. So if you actually need to talk like machine to machine, you don't have any identity information, client credentials works great for that. There's also resource owner password, which was originally created so if you can't pop a browser to log in, you could still send a username and password. So if you ever read an OAuth tutorial and they're using resource owner password, just stop reading. Shut it down. Because you're sending a username and password, and the whole idea with OAuth was, don't send a username and password. And so, yeah, not a good one. Assertion flow is allowing the authorization server to trust authorization grants from third parties. So it allows you to do SAML federation and does not support refresh tokens. And there's device flow. So if you've ever used Netflix or any other thing on your TV where it says go to this URL and type in this code, that's device flow for OAuth. So there's 6 different flows, and they're necessary because of how you get consent, who is making consent, and it offers and adds a lot of complexity to OAuth. So when people ask you if you support OAuth, are they asking you if you support all 6, right? Because I think that's one of the hard parts about a company like mine, where they have the ability to do implicit flow and resource owner password flow because they want to allow anyone to do anything, right? But if we were smart about it, we would prevent the ones that are a little bit more vulnerable, implicit and password resource. So what we did at Okta the last couple of years is if you create a new app, it would actually have those as not selected, right, by default. So if you want to use implicit flow or resource owner, you have to go in there and toggle them. When I first started 5-6 years ago, those were on by default, so it's nice to see those going away. If you want to play with OAuth and all the different flows, you can go to Aaron Parecki's site here at oauth.com/playground, and he allows you to basically, look at authorization code, PXE, which is proof key for code exchange, implicit flow, device code, and also exploring OpenID Connect. And so to summarize some of the misconceptions about OAuth 2.0, it's not backwards compatible with OAuth 1.0, and it replaces signatures with HTTPS for all the communication. When people talk about OAuth today, they're talking about OAuth 2.0. And interoperability exists, as it's not a protocol, but rather an authorization framework. It's not an authentication protocol. It's actually in the spec. You can see it there highlighted. So when people use OAuth for authentication, they're kind of doing it wrong. And OAuth 2.0 alone says absolutely nothing about the user, right? The access token can be a random string of characters. There's no identity information in there. So what happened was people were kind of abusing OAuth back in 2010, 2011, and a lot of it was Facebook and Google. And what they did is they had a /me or /me endpoint, and they would take an access token and call it to get the user's identity information, right? So it's almost a way of doing OAuth and authentication, but they needed to standardize it, so they came up with OpenID Connect. And OpenID Connect is for authentication, whereas OAuth 2.0 is for authorization. So it's a thin layer on top of OAuth. Without OAuth, OpenID Connect doesn't exist. So, they're very coupled. And so, what happened was they added a new signed ID token, which has to be a JWT. And even in the JWT spec, they call it JOT. So you know how GWT, we called it GWT for a while there? Well, that was just made up, right? That was a community. This, when you call it a JOT, it's actually, defined in the spec. And so there's also a user info endpoint. So instead of that /me endpoint, you can go to user info or whatever and get the user's information. There's also a standard set of scopes and claims for identities. There's profile, there's email, there's address, and there's phone. And there's also built-in registration. So if you have an issuer URL, you can go and discover all of those endpoints we talked about, the authorized endpoint, the token, the introspect, and those will all be defined in this JSON document. And so it supports high assurance levels and key SAML use cases for the enterprise. It was created by Google and Microsoft, and Okta participated in as well. So all that changes the flows a bit, but if you look in our original example, we had different scopes. So now we have standard scopes. You do have to use OpenID as one of the scopes, and then you can do profile, email, whatnot. As far as the token request, nothing changes. The token response, though, will have an ID token in it, right? And that is a JWT, so it's base64 encoded. If you decode it, then you can read what's in it. And so an OpenID Connect flow involves the following steps: the discovering of the metadata. So at that /well-known/OpenID configuration, there will be a JSON document that has all those endpoints in it and other information like what scopes are supported. And then you can perform the OAuth flow to obtain the ID token and access token. You get the JWT signature keys and optionally dynamically register the client application. So you can actually go to the DMV as part of it if it's enabled. Validate the JWT ID token locally based on built-in dates and signatures. And you can get additional user attributes with that access token at that user info endpoint. And then so if we go through the flow again, you'll see the scopes are now standardized, OpenID and profile. Everything else is pretty much the same, except when we exchange that code, we'll get back an ID token as well. And then we can use the access token to talk to the user info endpoint and get the person's identity information. And if you're not familiar with JWTs, pretty sure most of you are. There's a header, there's claims, there's signatures. You decode it, it looks like the values on the right there, where you have an issuer, a subject, an audience, time that expires. AMR is how they logged in. So if you used MFA, that would also be listed here, right? They did password, and then you prompted them for, second factor, and it would say that they did log in with the second factor. If you want to decode JWTs, our site at JWT.io makes it pretty easy. And people often ask, can you do OAuth without a browser? And the short answer is no. A browser is required. And there's 3 options if a user is involved. there's a web app which can handle a redirect, right? It comes back to localhost 8080 callback or whatever it is. If it's a CLI or a TV, you might use the device grant where you get a code and then they go to a URL and put in that code. And if it's a native app on Android and on iPhone, they actually will allow you to register a schema. So like https:// is a schema. You could do myapp://. And so when it comes back to that URL, it can actually launch the app and do the OAuth flow dance. So on laptops and desktops, we don't have that functionality now. So what a lot of people do is they'll spin up a web server just for a second to listen for that callback on localhost 8080 and then do it that way. So the desktop handling of OAuth isn't as elegant as it is on the devices. So there's also OAuth 2.1. The main goal for OAuth 2.1 is to kind of capture the current best practices in OAuth 2.0, as well as establish its well-established extensions under a single name. So proof key for code exchange is what PXE means, and it's basically a way of generating a client secret on the fly, so you're never storing it. That's how you should do mobile apps. That's how you should do SPAs, right? You can do it with authorization code flow. It works really nicely. Redirect URIs. Currently, a lot of IDPs, Keycloak, for example, will allow you to do *domain.com, and so the recommendation with OAuth 2.1 is make them explicit URLs, don't allow asterisks or wildcards in them. Implicit grant's gone, resource owner password grant's gone, and then there's some other things there that you can read. So the definitions of public and confidential clients has also been simplified to only refer to whether the client has credentials, whether it can store, a client secret. So now what you've been waiting for, right? OAuth and Java. So Java's OAuth support doesn't exist because the JDK doesn't contain APIs to write a web app, right? You have to use servlets or Jakarta EE to actually write a web application in Java. So the JDK, no OAuth there. But the cool thing is Jakarta Security 3.0, which just came out this year, supports OpenID Connect. And therefore, they support OAuth, right? You can't have one without the other. Oh, I also want to mention on the upside, Java 18 does contain a JWeb server, right? But it's just for serving up static files. So that's about all the web you'll find in the JDK. So let's get into Java frameworks. How do they support OAuth? So when Java EE stagnated in the early 2000s, the Java EE, or not 2000s, 2010, the Java EE community kind of did too, but eventually created Microprofile in 2015. And Microprofile is a standards-based effort to group the parts of Java EE that can be used to create a microservices architecture. So as part of Microprofile, there is a JWT auth specification. Even though it doesn't mention OAuth, it's very much a viable way to implement OAuth 2 resource server. So if you're using, a standard Microprofile framework, these are basically the properties you will use. You have an issuer and you have a public key location. So with Quarkus, they support Microprofile. You only need to add the properties that I mentioned previously and this dependency, and it'll all work. You'll be secured with OAuth, and if you get a valid access token, you can access that API with that access token. Helidon is very similar to Quarkus. The only difference is the dependency's coordinates, right? So we're still using those same property names. We just have a different dependency. Micronaut has good support for OAuth and good documentation on how to configure it with IDPs like Okta, Google, and GitHub. And it requires many more lines of configuration, but that's because I'm using YAML, right? That's my fault. I could easily use properties and have it, 2 lines or 3 lines of configuration here. Spring Boot basically allows you to do, something similar. You can use Spring Security, and it's the only framework that allows you to configure a resource server with 1 line of code. You would just specify the issuer. In this instance, I'm using Okta Spring Boot Starter, which works with Okta and Auth0, and we do audience validation as part of that. So that's why I have 2 lines here. So you might be asking about JSF or Wicket, and you could say that they don't have OAuth support. However, they both build on the Servlet API, so it's possible to use them with some framework that uses filters and servlets, like Spring Security. So even if your favorite framework doesn't have a dedicated security plugin for OAuth, it's possible that you could probably get something to work with servlets and filters. And as I mentioned earlier, Jakarta EE10 has OpenID Connect support. This is how you configure it. The cool thing is a lot of those initial properties, right, can be read from like a properties file or from environment variables or whatnot. The extra parameters one, we haven't figured that out. So if you're a micro-profile committer or you worked on the spec or whatnot, I would love to figure out how to make the audience be able to pull from that configuration file. All of our efforts so far, we haven't been able to figure that out. So to see some demos in action here, I got, what, 5 minutes? So I won't actually create the apps, but I will show you what they look like. So let's go here. So this is the repository, github.com/octadev/auth0 Java OAuth examples. And you probably don't see it, right? That happens to me a lot. I forget that I'm supposed to be mirroring everything. All right, and so there's the URL. So I'll just pull this up and we'll kind of walk through it. Oh, I also want to mention the t-shirt, right? I find your lack of security disturbing. These are Okta shirts, but we no longer make them. But the cool thing is you can go to shop.oauth.net and buy them there, and there's also hoodies. So just a plug for that. My coworker Aaron Parecki set those up. So in here, there's a demo.adoc. And if you want to check this out and just make everything run, clone the repo, read the README, it'll show you. But this basically walks through creating a Spring Boot, app at first using the Okta Spring Boot starter. We specify the dependencies of web and Okta and the base directory where to expand it to. And then the Okta Spring Boot starter is just a wrapper around OAuth 2 client and OAuth 2 resource server. So if you didn't want to use it, you could put both of those in here and it would have the same functionality, just the property names would be different. So you can, ensure it starts and log in, and then you can use the auth0 CLI to basically create an app and put it all in here and configure a resource server. So I do have this locally, and here's my Spring Boot app. And so if I was to go to that directory and run Gradle boot run, it would start up, and I already have these properties defined in here, the issuer and the audience, right? So what I can do is auth0 login, and now this is going to use device flow, right? How would you like to authenticate as a user? And then it gives me that code, and it's smart enough that if I press enter, it goes and enters that code at a URL. I confirm it here. It'll prompt me for consent, right? This is all the things the auth0 CLI can do. I accept it. I go back. It's waiting for the login to complete. The internet's a little slow here, but there we are, right? Now we're logged in, and so I can do auth0 test token, use that audience, and I can use like the default app here. Prompts me again. Login successful. Now I have an access token. So once I have an access token, I could set it to a variable, and then I could do HTTP IE, access the hello endpoint with that token, and it returns a 200 with that information. So if we were to look at that hello endpoint, you would see that all it's doing is taking the principal and getting the name. And so by default, that's just the sub claim in the JWT. And so that's Spring security. And the cool thing is, if we were to uncomment the client ID and client secret, you could also do login via browser with OpenID Connect. So right now, if I was to do localhost 8080, it would just give me a 401, right? It's only configured as a resource server. It's not going to do the OAuth dance or redirect anything. So to do that, I have to do auth0 create. I think I have it back here, my example. And I can grab this to create an auth0 app and register it. So we'll clear that. And we're just going to call it Spring Boot example. It gives us back a client ID that we can put in here and a client secret. Got to get the whole thing there. All right, and then we can stop it and restart it. And now if we go to localhost 8080, it'll redirect us. It'll have those, scopes in the URL, have the redirect URI in there. And so if we go localhost 8080, now it prompts me because we're sending in, scopes. We accept it. Now we're logged in, it says, hi, Matt Raible. So the difference is we're now serving up the home controller, and you can see here that it's not a principal. You can have the authentication principal as an annotation and get the OIDC user. And once you have the OIDC user, it's got all kinds of information, right? Not only the claims, but all the user's personal attributes, full name, first name, last name, all that kind of stuff. And so the other examples that I have in here that I won't go into, but you could try yourself, is Micronaut and Quarkus. So I've already got this example here. You just define the issuer and the public key. You're on Quarkus Dev, and you can access it as well. So very easy to configure. A lot of times it's just about that JWT library that they might implement. Oh, let me do the mirroring thing, or unmirroring. All right. So a few Java security frameworks aren't tied to a specific REM framework. I like to call them independently minded, but honestly, they seem to struggle as volunteer-driven versus funded open source projects. So there's Apache Shiro. It expects to operate in a servlet environment and can work with any framework based on servlets and filters. Remember, I have stickers up here for it. It has many integrations such as Play, Wicket, and Lift, but most are dated and kind of unmaintained. So Shiro can be adapted to work with OAuth 2. There's also Pack4J. It's a security framework with many sub-projects implementing OAuth 2, OIDC, and many others like SAML. I've heard its quality isn't that great, and I also believe it suffers because it's not tied to a particular framework. Spring Security has excellent integration with Spring Boot. Depends on Spring Framework. However, you can use it to secure any Java web app that uses servlet filter. So I have a Java EE example on the Okta blog that uses Spring Security, and you just add a couple dependencies. You add a servlet filter and then security configuration, and you're on your way. And you can do OAuth with any framework that supports servlet filters. Up to this point, everything we've talked about is OAuth clients. They require an identity provider to do OAuth flows. An identity provider has an OAuth 2 authorization server. Most of the prominent providers, Facebook, Google, Okta, have their own proprietary implementation. It's not available as an open source thing. The open source authorization servers that exist out there are Keycloak. It's very well known. JBoss, I think SSO is a product from Red Hat that uses Keycloak. So I don't call them a prominent identity provider, but I'm biased, right? So you could probably say that they are. And since I work for an OAuth 2 identity provider, it's my duty to inform you that using one of these is called build your own by the salespeople, right? And we recommend buying instead. So buy, don't build, right? But that's what our salespeople say. So from us, of course, but Spring Authorization Server, if you did want to build your own and tweak things to only support certain things, you could do that with Spring Authorization Server and WSO2 Identity Server. All those are open source Apache licensed. What about JavaFX? It's often touted as an excellent way to build desktop apps. The folks that usually recommend it, they're typically JavaFX experts, and they're Java enthusiasts that hate JavaScript, right? Electron is like the worst thing that ever happened, right? They're like, JavaFX did it better. But we have Slack, we have VS Code, all those are built on Electron, works pretty well, and it'll do OAuth in an Electron app. So JavaFX OAuth support is virtually non-existent. There is a Microsoft library that only works with Oracle JDK 8. And since then, no one seems to care. So I don't know if people just aren't doing authentication in their JavaFX apps, which is very possible, but it just doesn't seem to be something that people care about. You might ask, do Scala and Kotlin support OAuth? Yep. Play and Ktor both have OAuth support. And the most popular Scala web framework is still Play, and Ktor has Kotlin. But it's funny because back in the day, I remember I have a tweet from like 2011 or 2012 where the Play folks said that they were actually going to adopt Kotlin the Kotlin folks that they said they were going to make Kotlin work with Play, and then they went off and developed their own framework. So both of them have easy to use OAuth support. You can learn more about Java and OAuth in this blog post that I wrote last year. You can play with OAuth 2.0 and OpenID Connect at developer.auth0.com. If you like what I'm doing right now, talking about identity at a conference or halfway around the world, you can join our Auth0 Ambassador program, and we will help you do that. So we mentor you on identity. We help you develop talks, and we support you with Auth0 swag if you ever go to a conference. And if you subscribe to our Zero Index newsletter there, I get credit. So go to that URL, sign up, unsubscribe next week, but they'll see a bump this week and they'll be like, what happened there? And it goes purely to the Java team, which is me and my buddy Deepu. So thank you for coming. If you want to keep in touch, RaibleDesigns.com is my blog. I'm on mraible everywhere, Twitter, LinkedIn, GitHub. This presentation has already been uploaded to SpeakerDeck, so you can grab it there. And a lot of my code lives on Octadev. And so thank you for coming, and may the auth be with you.